Welcome to the program. Last bit of 4.1. What if you're given a quadratic in trinomial form and asked to graph? And let's say that you don't have the help of GeoGebra to do this. Alright, so what if you were given this standard coordinate axis and asked to graph this? How would you do it? Well, here's a step-by-step breakdown of how to do that. First, identify the coefficients. So, because we have a trinomial here, we have three coefficients to look for. The x squared coefficient will be our a, the x to the first coefficient will be our b, and our constant term will be our c, our coefficient c. And this is also important to regard the sign. So, coefficient A is 2 from that. Coefficient B is -8. And coefficient C is +6. Alright? So now we can find the vertex is given for any quadratic as -b/2a. So it will be -8. And be careful there because the formula has a negative, but we also see that our coefficient had a negative as well. So I'm recording both of them here. And then 2 times the value of a, which is 2, which gives us a +8/4, which is equal to 2. Alright? So, what this means is our vertex has, obviously, coordinates. Our x term is going to be 2. So if I go to our standard coordinate axis, I don't know the whole parabola yet. I don't know how to graph everything, but I know that at the point x equals 2, this will be our axis of symmetry for the parabola. Okay? Now, to get our y, we plug in 2 parentheses 2 squared minus 8 times 2 plus 6. Okay? I just took the given equation and substituted in the value 2. What does that leave us with? 2 squared is 4 times 2 is 8, right? 8 times 2 is -16 plus 2. So we have here 8 minus 16 is -8 plus 2 is -6. Okay? -6. Now, from here, I can basically figure out the vertex now. The coordinates of the vertex are here. 2, -6. So when x is 2, y is -6, which is down here. I need only know that I open up or down now, right? Before I do that, I've got to do step 3. Find the y-intercept, okay? Now, finding the y-intercept entails setting x to 0. Because if you think about it, this quadratic right here, if I make all the x terms 0, when x is 0, what is y? That's where it's going to hit the y-axis. So I will get 2 parentheses 0 quantity squared minus 8 times 0 plus 6. Sorry if that's a little sloppy. The first two terms go to 0 and I'm left with 6. So where this thing will hit the y-axis is up here at 6. Okay? And so let me evaluate for another value of x. Let me evaluate for, so we've done this several times now. We found our vertex with this. We plugged in for 2. Then we plugged in for 0 to get our y-intercept. So you can see you can tell the parabola is going to open up now, which we could have guessed because the 2x squared term at the beginning of the trinomial was positive in sign, right? But now step 4 says to evaluate for another power of x. So let's choose, just to see if the pattern holds, let's choose 4. Because if you look at the axis of symmetries here, we skip this point to get here, right? We can choose any point that we want here. Matter of fact, it could be, since this is the axis of symmetry, it would be useful to find if the value of y is around here when the input is positive 1. Y equals 2 positive 1 squared minus 8 times positive 1 plus 6. This will become 2, because 1 squared is 1 times 2 is 2. Middle term becomes negative 8, and this term here is plus 6. So I have what here? 2 minus 8 plus 6. 2 minus 8 is negative 6, plus 6 is 0 pair equals 0. So we have confirmed it, right? We have our parabola opening up. It is skinny, which we could have noticed because of the coefficient 2. Alright, made it skinnier by a factor of 2. And now we know that the other 2 points are symmetrical about the axis of symmetry. We can now, hopefully your graph looks better than mine. I'm not an artist, but this is ballpark what we are looking at, with the coordinates of the vertex being 2, negative 6, and we can confirm this with the GeoGebra. Thank you for watching.